Hello, everybody. We're going to take a look at lesson 3.4, which is talking about classifications of rigid motions. So if you remember back a couple lessons ago, I'm not sure which lesson it was talking about it, but a rigid motion is basically when you apply some transformations and you end up with the same shape, the same size, the same angles. Sure, this shape can translate, so it can kind of shift left or right or up and down, and it can reflect. It can do different transformations, but the key thing is whatever shape you started with, the image at the end, after you do one or multiple transformations, has to be the same exact shape. It can be reflected, it can be rotated around, it could be translated left, right, up, and down. But if you look at the pre-image and the image here, notice it's the same exact triangle, just the orientation of it is different. It's still a triangle with 90 degrees, 45 degrees, 30 degrees, right? They look exactly the same. They're the same size. This triangle isn't so big, and then this triangle is 10 times as big, right? That would not be a rigid motion. So remember, to classify something as a rigid motion, something can translate, which means move left, right, up, or down. It can rotate, so it can spin around. It can reflect across the line, kind of like these two right here, but it can't change the size of the shape, and it can't change the angles of the shape within the shape. So that's a big thing here. Let's look, they're kicking it off with a theorem. And remember, theorems are just kind of like rules that apply when you're dealing with this thing, right? So the first theorem, the composition. So when you put together of two or more rigid motions. So if you do 2 rigid motions, 3 rigid motions, 4 rigid motions, that's what that's talking about, is a rigid motion. So if you start off with a rigid motion, you do a second rigid motion, you do a third rigid motion. What you've done, all 3 of those transformations, if all 3 of those things are rigid motions, then overall the thing is a rigid motion. Okay? And they're trying to emphasize that here. So here's that pre-image. Again, if you forgot how I can tell that, look at the letters. Notice that that's just T. It's not T prime, and it's not T double prime. Okay? So when it's just T with no apostrophe, they call that the pre-image. And then it looks like this is the image, the first image. How do I know that? Again, because it's T prime. There's only one apostrophe. And then this is the second image. I know that because it's T double prime. There's 2 tick marks up in that top corner. So they started off with this 4-sided shape. It looks like they took that shape and reflected it. I'm going to get a pencil and kind of draw in my book. They reflected that pre-image across that line, okay? So they took it and they flipped it across that line. And then it looks like they took this shape and they rotated it, right? They kind of spun it around. So there's T prime, here's S, there's S double prime, I'm sorry, S prime. There's S double prime. So they took this shape and rotated it basically 90 degrees counterclockwise. Both of those transformations, the reflection and then that rotation of 90 degrees counterclockwise, both of those are rigid motions. So going from the pre-image to the second image, that is just an overall rigid motion. Right. Take a look at example 1. This is talking about proving theorems. If you remember, we skipped proofs back in the day, so we are going to continue to skip that idea of proofs. If you're interested in, why is this true, you can always read through this proof and kind of try to follow along. And basically, a proof is just like an overall justification of why something works in math. It starts off with a given. You apply different properties, different theorems, different rules, and then you get down to your final answer, what you were trying to prove. So again, we're going to skip the proof parts of this section. Example 2. Explore glide reflections. So they actually give you the definition on the next page. So I think what I want to do is kind of look at this definition first before we jump into this. So part C of example 2, there's a part C, but then it gives the definition of glide reflection. So again, the composition of a reflection followed by a translation in a direction parallel to the line of reflection is a rigid motion called a glide reflection. So when they're saying composition, they're meaning two or more things that are applied in the same problem. So the composition of a reflection, so that's first, followed by a translation. If you forgot, a reflection just kind of flips something over a line. It could be a horizontal reflection like this, or it can be a vertical reflection like this, where it flips from bottom to top or top to bottom. And then a translation is basically taking something and just moving it around the page. Left 7, up 3, right 2, down 5, something like that. So a translation is just where you slide it around the paper. In a direction that's parallel to the line of reflection, that's called a rigid motion and a glide reflection. Okay, so now I think we're ready to go back to example 2. Exploring glide reflections. So is there a rigid motion that maps this pre-image to the image? So there's the pre-image, the black shape, and then there's my image. Again, we've talked about it multiple times. How do I know that's the pre-image and that's the image? It all goes back to the notation. This is B, this is B prime. So when they're giving you that little apostrophe, B apostrophe, that's called B prime. And that tells you that this is the image. I start off with the pre-image, I do some transformations, and then I end up with the image. So is there a rigid motion that maps the pre-image to the image? You can kind of follow through this. It gets a little bit wordy, lots of letters, things like that. So be careful when you're reading through this, but let's just kind of take a look at the picture. They're labeling all these vertices. So you can see that this triangle didn't just shift, I don't know, right 5 and down 3, right? Because A was on the left, C is on the right. Now C prime is on the left, A is on the right. So it's not like they just took this triangle and went right and down, okay? So they might have had to rotate it, they might have had to reflect it. Let's kind of go through here and see. So observe what they're telling you here is that the measure of angle A is the same as the measure of angle A prime. And if you look, they're just visually looking at that, right? You could measure that if you wanted to, if you had a protractor, you could measure that angle, but they're telling you that. The measure of angle B is the same thing as the measure of angle B prime, and the measure of angle C is the same as the measure of angle C prime. So that's important. Remember, if something's a rigid transformation, the overall shape can't change. So we can't go from this black triangle to a red triangle that's twice as big or 3 times as small. That's not a rigid transformation. Another thing is too, all these angles have to be the same. So if angle C is 90 degrees, C prime has to be 90 degrees. It can't change. So they're also emphasizing that the side lengths are the same. So the side length of AB, so if you whipped out like a measuring tape, or if you just calculated the distance of AB there, it's the same distance as A prime B prime. AC is the same distance as A prime C prime, and BC is the same distance as B prime C prime. So what they've shown you so far is that all 3 of these pre-image vertices, all these angles, are equal to the image angles. And then also my side lengths of my pre-image, that's equal to my side lengths of my image. So what they did there is they had proven that that is a rigid transformation. We went from the pre-image to the image using rigid transformations. Does a reflection, translation, or rotation map the pre-image to the image? And specifically what they're asking is, does one single reflection, or one single translation, or one single rotation? And when you look through here, I don't think it does. I can't just translate this left and down. It's not the same triangle. I can't reflect this triangle across any line to get my image. And I can't rotate this triangle around any point to get my image. I think just by looking at it, I'm going to have to translate it left, right, up, and down, and then reflect it. So I'll have to do a composition of rigid motions. So that's what they're emphasizing here. They're checking different things, and then they say it's not a translation, it's not a rotation, it's not a reflection. But I think if we can combine multiple transformations, we should be good. And I think that's what they're going to tell you in part C. So part C. What composition? So now we're allowed to do multiple transformations of two rigid motions map the pre-image to the image. So let's read this. Because triangle ABC has a clockwise orientation, what they mean is as you read this clockwise, as you go in that direction there, it's going A, then B, then C. And then the image has a counterclockwise. So if you start at A, you don't go in a clockwise motion to go in the order, right? If you go clockwise, it's A, C, B. Not like up here where it was A, B, C. So because of that, orientation is not preserved. This means that one of the rigid motions must be a reflection. So it's not like they just move this right and down. The orientation of those vertices changed. So that's what they're emphasizing there. Because that orientation changed, if you go clockwise, A, B, C, and now it's A, C, B, they must have reflected that image. So here they're telling you reflect that pre-image across K. Do they give you K? Is it this red line here? I don't see any. Oh, okay, they're telling you right here. Reflect triangle ABC across K, the line with the equation x equals -1. So you could see this red dotted line here. If I reflect this pre-image across that line, x equals -1, you'll see that the distance was preserved, right? So if this is my line, this dotted line, from B to my line of reflection is 2 units. So my image has to be on the other side of that line of reflection 2 units away. So this is B prime. C is 2 units away. So C prime has to be 2 units away. And then A is 1, 2, 3, 4 units away. So A prime has to be 1, 2, 3, 4 units away. So now I'm sure you can see that after I reflected that pre-image across that line of reflection, now I can just take this triangle and slide it down. How far would I have to go? A goes down 1, 2, 3, 4, 5 units. So I'm betting C is going to go down 1, 2, 3, 4, 5 units. And B prime is going to go down 1, 2, 3, 4, 5 units. So if I can do a composition of rigid motions, right? If I can reflect it and then translate it down 5 units, that'll work. So let's see what they say down here. Then translate the image down 5 units. So here's that notation. Remember, I'm not super worried about you deriving this notation and being able to write it, but make sure you can read it, right? You're not translating right 0, down 5, and then reflecting. Make sure you're starting with this rigid motion that's on the right, and then you'll do the rigid motion that's to the left of that. So we're going to start with a reflection, and then we'll translate it. Remember these numbers, this means right 0 and then down 5. So we've already talked about this definition, a glide reflection. So it's talking about starting off with a reflection, and then we can translate it a number of units to get whatever we want. Number 3. Find the image of a glide reflection. So basically, after you have a pre-image, do something, right? 2 different things, reflect it and translate it, and then find that image, that aftermath of it. So a digital artist is reproducing a tire tread pattern from a partial tire print from a crime scene by applying a glide reflection. She uses the rule, translate this 0 units to the left or right, but it's going to be 0.1 units up. And then also we're going to reflect it across the y-axis. So remember, we're going to start with that right side, that right rigid transformation. Then we'll translate it, okay? To generate a pattern, confirm that her rule can be applied to the partial pattern that was taken from the crime scene, okay? So step one, apply the first rigid motion. Remember, it's not going to be the first one that you're reading from left to right. It's always going to be that second or that rigid motion that's on the far right. So the first rigid motion is going to be reflected across the y-axis. You could see we have a tire tread mark. They've kind of overlaid an X and Y axis there. And then we want to reflect that image across the Y axis. So the Y axis is this vertical axis that goes straight up and down. So let's take a look. I think that the yellow is the pre-image. So what we're going to do is take that yellow space or that yellow little, I don't know, pattern, and we're going to reflect that across across the y-intercept or the y-axis. So take that yellow thing and reflect it across the y-axis. And then apply the second rigid motion. Again, we always start with the right. So the second rigid motion is a transformation. That's what T stands for. And then this first number tells us our X. The second number tells us our Y. So we're not going to move left or right at all. We're just going to move up 0.1. So if you go from this, what is that? That's either black or blue. I can't tell. I think it's blue. That little blue piece right there. If you take that and you shift that piece up 0.1 units, take a look at that red overlap. It looks like it lays right on top of that print that's in the ground. So the rule appears to map the pieces of the partial pattern onto itself. Key thing here is, though, let me make sure it's crystal clear. When you have a composition of transformations like this, these rigid motions, always start with that rigid motion that's on the right, and then work yourself to the left. So start with reflecting, then transformation. Here we got some more kind of rules. Remember, there's just fancy names like theorems and corollaries and things like that. They're just basically rules in math land, right? Things that we have to follow, things that we know to be true. So any rigid motion is either a translation, a reflection, a rotation, or a glide reflection. Remember that glide reflection that was on that previous page where you're going to reflect, then translate. So any rigid motion is one of those four things: a translation, a reflection, a rotation, or a glide reflection. And then corollaries. Any rigid motion can be expressed as a composition of reflections. Okay, so basically I can take a shape like this shape here, and I can do a whole bunch of reflections. A composition just means multiple of those things. So if I have a composition of reflections, I can basically prove any rigid motions with that. Example 4, what is the glide reflection that maps the pre-image to the image? Make sure I'm clear here for you. This is actually not the image. This is the second image. I know that because there's 2 tick marks there, right? So basically there's the image, and then they did some type of transformation, and then they have the final second image. That's where they're wanting us to go. So determine the glide reflection. You can work backwards. Remember, we always start off with a reflection with glide reflections. So we're going to start off with a reflection, and then we work backwards to a translation. So what they want to do is start with a translation, and then we'll do the reflection. We're kind of working backwards here. So if we look at this image, or this pre-image, JKL, and then here is the second image, what's basically happening here? So they're saying determine the translation. So determine how far you shifted this thing left, right, up, down. You just basically took this pre-image and you slid it around on your paper. So first determine the translation that vertically aligns J double prime with J, and then obviously all the other images with the pre-image, okay? So let's take a look at J. If I vertically align J with J double prime, it looks like I have to move J 1, 2, 3, 4, 5. If I move J 5 units to the right, it's going to be vertically aligned with J double prime. Same thing with K. If I move K 1, 2, 3, 4, 5 units to the right, it's going to be vertically aligned. Vertically aligned is just a fancy word of saying on top of, right? They're going to be on top of each other. And same thing with L. Move it 5 places to the right, it's going to be right on top of L double prime. So that is the first translation. I don't think they're moving it up or down. They're just moving it right 5 units. And then determine the line of reflection. Let's go ahead and draw in our book a little bit here. If I draw in my book and I move K 1, 2, 3, 4, 5 units to the right, L 5 units to the right, and J 5 units to the right. So K, J, L. So hopefully you can kind of see that those two are the same thing. What they want to do now is they want to figure out what the first piece, right? The first piece of that glide reflection is. So remember, the first piece is always a reflection. So how can I start with this first image and get the red second image? Well, it looks like if I reflect this across the line, I don't know, about like that bottom part is going to come up top. The top part is going to flip down below that line of reflection. So to come up with this, all you have to do is count the distance between the pre-image and the image points. So how far is it from J prime to J double prime? It looks like it's 1, 2, 3, 4, 5, 6. So if it's 6 units between J prime and J double prime, I know that 3 units up, halfway up, has to be that line of reflection. Now you might be saying, how do you know that? Remember, distance is always preserved across the line of reflection. So if this is my line of reflection, and we're going to call that y equals 1, right? That's my line of reflection underneath my pencil right there. From J double prime to that line, that's 3 units. From J prime to that line is also 3 units. From L double prime to that line is 3 units. From L prime to that line is 3 units. From K double prime to that line is 2 units. From K prime to that line is 2 units. So all of those distances have to be equal between the pre-image and that line of reflection, as well as the image in that line of reflection. So that's how I know that that line of reflection has to be y equals 1. Otherwise, the distances wouldn't be the same. So I figured it out. The translation, it looks like they just took that pre-image and they shifted it right 5 units. And then it looks like once you shift that image right 5 units, you've got that line of reflection, and then that will get you from your pre-image to your second image. Just remember, when you're writing this, when you're annotating this, that reflection comes first. It's not written first from left to right. It's got to be kind of written backwards. The first thing that you're performing is always a reflection, and it's always on the right. And then you'll do the transformation. I think the 2 things we found is that we want to shift it right 5 units. So you're seeing it's a transformation, 5 units to the right and 0 units up and down. And then we said we want to reflect across that line y equals 1. So they're just calling that line y equals 1. They're calling that L. So they said reflect across L. Then the concept summary on the top of page 133, it just kind of goes into detail about everything we've talked about so far. They're emphasizing certain things here, like with reflections. This line M, right underneath my pencil, that's my line of reflection. So you'll notice that they're talking about distance here. The distance between my pre-image and that line of reflection. is the same as the distance between my image and that line of reflection. I know that because they both have one single tick mark there. The distance between C and that line of reflection is the same distance as C prime to that line of reflection. And I can tell that because it's got two tick marks to measure out both of those things. Translation, this is just talking about, sliding this image, this pre-image around your paper. So specifically, they want you to translate it. X is -2, Y is -3. So that means I'm going to take each point and I'm going to move it left 2 and down 3. So A went left 2 and down 3. B went left 2 and down 3. Same thing with C. Rotation, we're not getting into this. We actually skipped, 3.3. I think that was all about rotations. The reason we skipped it, if we were in class, we would do it, but we're not doing it right now is because you would need tools. You'd need protractors, and the district didn't want to get into issuing tools and having people be responsible to go and get tools and then track them and things like that. So we're not going to actually be talking about rotations as far as measuring them. But we can talk about rotations as far as like this image definitely didn't just slide right and down. It didn't reflect. You could see visually that it rotated, I don't know how many degrees, so many degrees clockwise. So I took this pre-image here, I took it and then I rotated it, 45 degrees, 50 degrees, however many degrees, counterclockwise. So we're not going to get into the actual measurements of rotations, but just being able to identify that a figure rotated is how far we're going to go into that. And then a glide reflection, just make sure you're remembering that there's an order here. Glide reflections have to reflect first and then translate. Reflect first, then translate. So it looks like they took their pre-image and reflected it across line M, and then they translated it right, 1, 2, 3, 4 units to the right. All right, we are on page 134. We're going to take a look at this practice section. What are two rigid motions with a composition that maps the pre-image to the second image? Am I reading that right? Nope, to the image. So what two rigid motions is going to take you from this pre-image to the image? Let's take a look at the first one they're talking about when you are reflecting something. Remember what they said, this triangle is JKL. So if we start at J from the pre-image and we go counterclockwise, it looks like we're in the right order, right? J, K, L. So let's see what happens when we go up here and check that. If we start at J prime and we go counterclockwise, let's see if we're still in the right order. J, L, K. So based off that example we did a few minutes ago, because the order changed when we go clockwise, I know that this image was reflected. So we're gonna have to figure out what that is or where that's at. Let's check if anything else, if they just reflected it. So if they just reflected this pre-image, then it would just be somewhere over here, or maybe if the line was here, it would be somewhere up here. But notice that they couldn't have just reflected it, even if my line was like right here, because K would be that first point right there, right? So they didn't just reflect it, they must have done something else. So I think what I want to do is, let's see if we can shift this thing. And just like that example taught us a few minutes ago, let's stack the pre-image and the image points on top of each other. So if I move K 1, 2, 3, 4, 5, 6 units to the right, okay, 6 units to the right, let's move L 1, 2, 3, 4, 5, 6 units to the right. And let's move J 1, 2, 3, 4, 5, 6 units to the right. So here's our triangle, just translated. 6 units to the, I think I said right. I think I meant left. Sorry, 6 units to the left. I know my left from right, I promise. So I took this pre-image, I shifted it left 6 units. Now if we take a look at this, now we can imagine if we have a line of reflection somewhere around there, it looks like that this bottom triangle reflected across that line and created this red triangle up top. So now the thing is we have to figure out where that line's at. Remember, distance is preserved. So how far is K away from K prime? 1, 2, 3, 4 units away. So if the total distance is 4, that line of reflection has to be smack dab in the middle. That's y equals 1. How do I know that? Again, if it's not in the middle, then the distances aren't going to be preserved. From this K to that line of reflection is 2 units. So K prime has to be 2 units away. L is 1, 2, 3, 4 units away. So L prime has to be 1, 2, 3, 4 units away. Same thing with J. J is 1, 2, 3, 4, 5 units away. So J prime has to be 5 units away. That line of reflection has to be dead smack dab in the middle of those 2 shapes. So what are 2 rigid motions with the composition that maps the pre-image to the image? So the first is going to be reflection. So I want to reflect across line y equals 1. And then I want to translate it. Okay, so reflect and then translate. So I think what I'm going to do is reflect this across that line y equals 1. That will be my first K. So there's K. Is that 1, 2, 3, 4? 1, 2, 3, 4. There's L. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's J. J, K, L. Why did I redraw this up here in quadrant 1? Well, remember, if this is a composition, these things have to talk about reflections first. So I'm going to reflect across the line y equals 1, and then I'm going to translate everything 6 units to the left. So it'll look something like this. Reflect across y equals 1, and then translate, what did we say, 6 units to the left. So -6, 0. And then that's going to be triangle ABC, and that'll give us triangle A prime, B prime, C prime. Just don't forget to write these things backwards, right? Reflect first, then translate. For exercises 13 through 17, given A, B, and C, determine the coordinates of the vertices of its image for each glide reflection. Suppose P is the line with the equation x equals -3, Q is the line with the equation y equals 9, and R is the line with the equations y equals -2. I think it was last week where I basically put all of this in Desmos just to prep it and be able to present this a little bit cleaner than me just kind of writing on graph paper, because that can get a little bit messy. Especially my penmanship is garbage, and I don't want to confuse you just by screwing something up on paper. So what I want to do here is go ahead and share my screen. Okay, I think I'm recording again. I hope I didn't screw that up. All right, I should be recording my screen now. I want to kind of start pointing these things out. So we're on number 13 in our practice problems on page 134. Number 13 is saying translate 0, -2 and reflect across the y-axis, triangle ABC to give us our image, triangle A prime, B prime, C prime. So the order of these things is reflect across the y-axis and then translate 0, -2. So let's see if I can get these things up here. So here are our 3 points that they give us up in the directions. 6, -4, they're calling that A. B is 3, 8. C is -7.9, so that's all good to go. You can see those 3 points up here on my screen, A, B, and C. Number 13 wants us to reflect across the y-axis first. So I'm going to turn that off and on again so you can see the y-axis right here, vertically right here. You can see it turn red, right? So there's the y-axis. That's what we're reflecting across right now. And then we're going to translate each of those points 0 units to the right and 2 units down. So B is going to go reflect across, let's start with A. Reflect across the y-axis. So A is going to go 1, 2, 3, 4, 5, 6 units to the line of reflection. So it's got to be 6 units on the other side. 1, 2, 3, 4, 5, 6. So right there where my pointer's at, that is going to be A prime. So let's see. I'm going to have to go down there and type it in. So that is -6, comma, -4. And that is A prime. Same thing with B. It looks like it's 1, 2, 3 units away. So B prime has to be 1, 2, 3 units away. So that's at -3, 8. We'll call that B prime. And then C is 1, 2, 3, 4, 5, 6, 7 units away. So C prime has to be 7 units away on the other side. So that's going to be at 7, 9. And we'll label that C prime. Okay. Let's get these all the same color, just because that messes with my brain. Okay, so now you can hopefully see that that image, or that pre-image, the black points, reflected across that line, x equals 0, the y-axis, to give us our image points, the blue ones. And then they want you to translate them 0, -2. So I don't want to move these points left or right at all. I just want to move them down 2. So this is going to become A prime is just going down 2. So it's going to go from -4 to -6. B prime is -3, 8. So it's going to go down 2. So it's -3, 6. C prime is at 7, 9. So it'll go down 2 to 7, 7. So hopefully you can visualize this. There's no way to connect the dots, or at least no way that I know of. But hopefully you can visualize A, B, C as a triangle, and then A prime, B prime, C prime as a triangle. And hopefully you can see that it reflected across the y-axis, and then it all went down 2 units. All right. Let's go up and check the next one. So I think number 14 is it's kind of the same thing. You're dealing with the pre-image and the image, the same points. Those aren't changing throughout this whole idea from 13 through 17. But the order, or the things that they want you to do, are translate 4, 0 and reflect across the x-axis. So there is my x-axis. Again, you could see it. The x-axis gets highlighted red. Hopefully you can see that. My 3 points there are my pre-image. So A, B, and C. And again, just like last time, I'm going to reflect B and C onto the other side of the x-axis. And then I'm going to reflect A onto the other side of the x-axis. So it looks like A is 1, 2, 3, 4 units away. So it's going to be on the other side of the x-axis 4 units. So it's going to go up 1, 2, 3, 4. That point is 6, 4. So there is A prime, 6, 4. All right. And then B prime, or I'm sorry, B is 1, 2, 3, 4, 5, 6, 7, 8 units away. So it's got to be 8 units away on the other side. So B prime should be at 3 comma negative 8. So there's B prime. C, it looks like it's 9 units away from the x-axis, so C prime has to be 9 units away from the x-axis as well on the other side. So that's negative 7 comma negative 9. All right, so again, use your imagination. I wish there was an easier way, or maybe I should look that up to see if I can connect those dots, but as far as I know, there isn't one. I'll ask around though, because I think that would help people out. But again, just visually see A, B, C being connected by a triangle, and then A prime, B prime, C prime connecting to form a triangle. And hopefully you can see that the top half just flipped down below, and the bottom half, the A value, flipped up above. Number 14 also wants us to translate it 4 comma 0. So that means 4 units to the right because it's positive 4. And then 0 units up or down. So all of these blue points, this image, they're all going to shift 4 units to the right. So instead of 6 comma 4, it's 10 comma 4. Instead of 3 comma 8, negative 8, it's 7 comma negative 8. Instead of negative 7 comma negative 9, it's going to be negative 3 comma negative 9. So reflect first, then translate. Number 15, dealing with the same pre-image. They want you to translate 0 comma 8 and reflect across line P. Line P is x equals negative 3. So x equals negative 3, that's line P. And if you're reflecting across that line, right, all the stuff on the left, C is just going to flip to the other side. B and A are just going to flip to the other side. That's all reflection is. Just make sure the distance is preserved. So for example, from C to that line of reflection, that's 1, 2, 3, 4 units away. So C prime has to be on the other side 4 units away. 1, 2, 3, 4. So C prime is going to be at 1 comma 9. All right. B looks like it is 1, 2, 3, 4, 5, 6 units away. So B prime is going to be 1, 2, 3, 4, 5, 6 units away on the other side. Negative 9 comma 8. And then same thing with A. A looks like it is, what, 9 units away? 1, 2, 3, 4, 5, 6, 7, 8, 9. So A prime has to be 9 units away. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that looks like it's negative 12 comma negative 4. And then the second part of this, reflect across line P and then translate it 0 comma 8. So 0, that means these points are not moving left or right at all. They're just moving up 8 units. So each of these points, the y value is going to add 8 to them. So negative 4 plus 8 is positive 4. 8 plus 8 is 16. 9 plus 8 is 17. So every point just moved up 8 units. All right, I think these other ones are exactly the same. I don't think I really need to take the time to go through 16 and 17. They're both reflecting across line Q and line T. These lines are just, line Q is y, line Q is y equals 9, and line R is y equals negative 2. So nothing really changed. It's the exact same steps as the 3 before. So just to kind of save time a little bit, looks like I'm already at like 47 minutes. I think I'm going to skip 16 and 17. But if you are looking at 16 and 17 and you're struggling, you look at the solutions manual and you still can't figure it out, please email me. I'd be happy to either record a quick lesson on those two or just meet you in Zoom and just explain them real quick like this. But again, just to save time, I think I'm going to go ahead and skip those two just to fast forward us a little bit. They work exactly the same as the last three, though. So for number 18, 19, and 20, write a rule for each glide reflection that maps the pre-image to the image. So I know I already preloaded this stuff. Let's go ahead and clean this up a little bit and see what stuff I can get rid of here. So the points are 7, -2. Okay, these ones right here. And then here is the image. All right. So this was asking for the glide reflection. So you know that these points, somehow they went through a reflection process and then they went through a translation process. So they were reflected across some line and then they were kind of shifted left, right, up or down, right? To get to the points that they're at. It looks like, let me go down here so I can type in a line. It looks like if I take E and I shift it left 1, 2, 3, 4, it would be right below E prime, right? It looks like F, if I shifted it left 4, 1, 2, 3, 4, it's not right below F prime. So I don't think I have to shift it left. Let's look at shifting these up. If I shift E up 1, 2, 3, it would be right next to E prime. If I shifted F up 3, 1, 2, 3, take a look at that. It's right next to F prime. And then if I shift D up 1, 2, 3, it's going to be right next to D prime. Huh, okay. So let's go ahead and shift these things up 3. So here's my points. I'm going to shift them up 3, which means I'm adding 3 to this. So -2 becomes 1. 9 becomes 12. 9 plus 3 is 12. And then 6 plus 3 is 9. Take a look at that. After I shifted these things up 3, they're right next to each other. And then looking at this, I think there's just going to be a line of reflection that runs across the center right there. Okay, let's find what that line of reflection is. How far apart is E and E prime? It looks like it's 1, 2, 3, 4 units apart. So that line of reflection has to be smack dab in the middle, 2 units to the left or 2 units to the right. So that's going to be x equals 1. Let's go up here and change. We'll do this one. X equals 1. Now let's verify. Let's make sure that either I didn't screw something up or the computer's not messed up. More than likely I screwed something up, but let's check. So once we shifted these pre-image points up 3 units, it looks like the pre-image is 2 units away, and so is the image. The image is 2 units away. The pre-image is 1, 2, 3, 4, 5, 6, 7 units away. The image is 1, 2, 3, 4, 5, 6, 7. The pre-image is 1, 2, 3, 4, 5, 6 units away. The image is 1, 2, 3, 4, 5, 6 units away. So I think we found our composition, right? The first thing we want to do is reflect it across this line, x equals 1. And then we want to shift all of these pre-image points up 3 units, right? Those are the 2 things we did. Reflect across line x equals 1 and shift those pre-image points up 3 units. So if I was writing that, it would look, let's see if I can, I'm going to go ahead and write this, and then at the end I will show you what these things look like. So for number 18, I'm going to write it as from left to right. Remember, we always do the reflection first, but we write the translation first. So it's going to be translate. I want to go up 3 units. So it's going to be 0, 3. And then I want to reflect across the line. What was it again? X equals 1. And that's going to be triangle DEF. And that's going to give me triangle D prime, E prime, F prime. So again, I've got a little screen down the bottom of my hand, the bottom right-hand corner, but I don't know if you can see that on this recording. So I'm going to show you these at the very end. So that's 18. Number 19. Let's get these all cleaned up. It takes me a minute to uncheck everything and turn everything off. So I apologize for that. Okay, so 19 is going to be, that's going to be my pre-image. And then the green is going to be my image. So again, we know the order of these things. We know we have to reflect first, then translate. It doesn't really matter which one you find first. We could go the opposite and find how far we have to translate it first. But as long as you find both of them, just make sure you write them in the correct order. So let's look at this. It looks like D, it looks like if you put a line right here at X equals -4, I'm gonna go ahead and do that for you. There we go, right? It looks like that D and D prime are reflecting across that line, correct? But now look at E and E prime. If I reflect E across this red line right here, it should be somewhere over here on the left. So I don't think that that's my line of reflection. Let's keep looking at this. The more I look at this, the more I'm seeing that E and E prime are almost on top of each other. F and F prime are almost on top of each other. So here's what I think is happening. I think I want to move all of these pre-image points 2 units to the right. Because take a look at D to D prime. 1, 2 units to the right. So let's move all these 2 units to the right and see if that matches up. So 2 to the right. So if I want to move 2 things to the right, the positive direction, it's going to basically add 2 to them. So -3 goes to -5 goes to -3. 1 goes to 3. 6 goes to 8. Well, look at that. D and D prime are right on top of each other. E and E prime are on top of each other. F and F prime are on top of each other. So I think that translation, didn't I say, I think I said 2 units to the right. Let me double check before I mess that up. 1. On the right one. Let me make sure that I got these things written correctly. Okay. So this one is -3, 8. Oh, I think I am on the wrong problem. D was 7, -2 for number 18. See, I just got too much garbage here. Yeah, it's none of this junk. This is all old junk that I didn't need. So let's back up for a second. 7, -2. Let's get rid of all this garbage before 7, -2. Oh my gosh. Did I totally just jack this thing up? Okay, I'm gonna pause this for a second and I'm gonna get this thing fixed. All right, I figured it out. I'm such an idiot. I wasn't paying attention. So what I was doing, what I was throwing myself off on was I had these pre-image points, and then remember I would say let's shift D 2 units to the right. So I would go over here and I would shift it 2 units to the right, and then I shifted E 2 units to the right, so I added 2 to my X value. I shifted F 2 units to the right, so I added 2. And then I was like, wait a second, those points aren't the points in my book. But I was an idiot, sorry. So there's my brain fart moment. So excuse me for that. So I think I was still on the right track. We'll verify from here on out. So here are my pre-image points. I went ahead and added 2 to each of the X values because I wanted to shift all of those points 2 units to the right. Now they are all on top of each other. Now, if you look at this, E's are stacked up, F primes are stacked, or the F's are stacked up, and D is just on top of itself. So what I think is happening here is we have this line of reflection right here at Y equals 8. Let's go back up here and we'll mark that here, Y equals 8. And then take a look. Once we shifted all of those pre-image points, those black points 2 units to the right, and then reflect across this line, E is 1, 2, 3, 4 units away. So E prime is 1, 2, 3, 4 units away. F is 1, 2, 3, 4, 5 units away. So F prime is 5 units away. Since D is right on that line of reflection, D prime is also going to be right on top of that line of reflection. Okay? So I think that's it. I think we want to shift all of these pre-image points 2 to the right, and we want to reflect across this line, Y equals 8. So I'm going to go ahead and write this down on my paper, number 19. Again, you always put the reflection, you always do the reflection first, but you write the translation first. So I want to translate all of these points 2 units to the right. So it's going to be translate 2, 0. And then our reflection is across the line Y equals 8. Triangle DEF, which produces our image, triangle D prime, E prime, F prime. Woo! Sorry. That was kicking my tail. I don't know what I was doing there. I was changing things up and marking things and blah, 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 blah. That's what I do. That's what I get for getting ahead of myself. Okay, let's go ahead and hide all of this junk. I think I can actually delete it, but I don't want to delete it because then it just makes more work for me to type everything in if I screwed it up. So let's just hide it all, and then hopefully I'll get this last one right. Okay, number 20. D is 0, 4. Perfect, there we go. So there is our pre-image for number 20. Here is our image for number 20. All right, let's take a look. Where are we at? So here we can see it all. It looks like, remember that little trick they showed us back in these examples? D, E, F, if you go in that alphabetical order, it looks like we have to go counterclockwise. Think of a clock, right? A clock goes clockwise. 12, 1, 2, 3, 4. It goes in this direction here. They call that clockwise. Here it looks like the order DEF is going counterclockwise. It's going to the left. So let's see if these are going counterclockwise. D, nope, because it should be E, then F. So that example that we saw a few minutes ago, well now it was like 20 minutes ago, it says that when that order changes, when you change from DEF to DFE, you know that a reflection happened, okay? So now our job to find that reflection. So it looks like if I could snip out that triangle there and just drag it all to the left, like 5 or 6 units, it looks like the D's would be on top of each other, the F's would be on top of each other, and the E's would be on top of each other. So let's go ahead and do that. Let's figure out how far we gotta go though. So D has to go 1, 2, 3, 4, 5, 6 units. And then D and D prime are right on top of each other. So let's move each of these pre-image points 6 units to the left, which means I'm subtracting 6. So 0 minus 6 is negative 6. 6 minus 6 is 0. 9 minus 6 is 3. Take a look. It looks like each of these points are stacked right on top of each other. And if I created a line across the middle, somewhere I'm guessing around y equals negative 2, that should satisfy our line of reflection. But let's look, let's count them out and verify. So E is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units away from its image. So from my pre-image to my image, if that distance is 10 units away, that line of reflection has to be right there in the middle. So 10 divided by 2 is 5. So if I change E and I go 1, 2, 3, 4, 5 units away, that line at y equals -2 is going to be my line of reflection. Let's go write that. Y equals -2. I think I need a lowercase y. And then there's that line. Again, you can verify this. E is 5 units away. E prime is 5 units away. D is 6 units away. D prime is 6 units away. F is whatever, I don't know, 10 units away. F prime is 10 units away. It all works. So in this case, I think we moved each point 6 units to the left, and then we reflected across the line y equals -2. So that's what I'm going to write down on my paper, and then I'll show it to you. So translate each point 6 units to the left. So it's going to be t -6, 0, and then reflect across the line y equals -2. Triangle DEF will give me triangle D prime, E prime, F prime. All right, I'm gonna try to get back to our screen here, so hopefully this works. Stop sharing, perfect. All right, so like I promised, let me show you these real quick. Let me just emphasize what they're talking about here. Remember, you're always gonna do the reflection first, but the way you write it is you start off with the transformation. So for number 18, we wanted to move 3 units up and reflect it across the line x equals 1. For number 19, we wanted to move 2 units to the right and reflect it across the line y equals 8. And for number 20, we wanted to move it 6 units to the left and reflect it across the line y equals -2. Keep in mind that these points right here, this tells you your x and y. So this value, this first one, will tell you to move left or right. This second value will tell you to move up or down. And then the last one, let's knock this last one out and be done. I got to go make a pumpkin pie for my family. So from scratch, by the way. So thank you very much. Hopefully you're giving me some credit. 21, and I'm not saying scratch like from the can. I'm saying like roasting pumpkins and pureeing it and like making a homemade pumpkin pie from scratch. So I'm going to be pretty impressed with myself. I hope you're impressed with me too. Number 21. So I think essentially what they're doing is asking you the same thing, but now they just have it on graph paper. So starting with this pre-image, did they move it left, right? Did they reflect it? What happened here? Well, it looks like they're moving D to stack it right on top of D prime. It looks like it's going to go 1, 2, 3, 4, 5, 6 units to the left. And then it's right on top of D prime. So if we move F 1, 2, 3, 4, 5, 6 units to the left, it's also right on top of its image. Same thing with E, 6 units to the left, it's right on top of its image. So let's go ahead and do that. There's D, there's F, and then there's E. So there is my translation, 6 units to the left. And then hopefully you can see that that triangle up top is just reflecting across the line to give me that red image at the bottom. So remember, to find this line of reflection, it's going to be halfway between each of these points, each of the pre-image and the image. It doesn't matter which point you pick. I usually pick the 2 that are closest to each other just because it's less to count. So F is 1, 2, 3, 4 units away. So I know that line of reflection, if the total distance is 4, the line of reflection has to be 2 units away. So F is 1, 2. So it looks like it's going to be the x-axis is our line of reflection. And I think it works. F to the line of reflection is 2 units. F prime is 2 units. E to that line of reflection is 3 units. E prime is 3 units. D to that line of reflection is 5 units, or hold up, 6 units. D prime to that line of reflection is 6 units. So I think for 21, We wanted to shift these left 6 and then reflect across the x-axis. So translate left 6, so negative 6 comma 0. Reflect across the x-axis, triangle, DEF will give me its image, triangle D prime, E prime, F prime.